Hi students, welcome back to my YouTube channel Rahman Chemistry Coaching Academy. Today we are going to discuss and explain the Coulson's and Moffitt modification. Coulson's and Moffitt modification is also known as bent bond theory or banana bond theory. This concept was developed by Charles Coulson and Moffitt to remove the limitations of base-10 theory regarding stability of cycloalkanes. The main purpose of this theory is that to explain why cyclopropane and cyclobutane are less stable as compared to cyclopentane, cyclohexane, and other cycloalkanes. Look at to this slide, which shows the structure of open chain propane and the cyclic structures of cyclopropane. In all these structures, carbon atoms are sp3 hybridized. According to label model, the bond angle in open chain sp3 hybridized carbon atom is normal tetrahedral bond angle of 109 degree 28 minutes. Also, according to base-10 theory, the bond angle in cyclopropane is 60 degree as shown. In open chain propane molecule, the carbon-carbon bond is formed by the maximum head-on overlapping between sp3 hybridized orbitals and thus result in a stronger sigma bond. Same should be observed between sp3 hybridized orbitals of carbon atoms of cyclopropane, which may result in the formation of a stronger carbon-carbon sigma bond, but practically this is not possible. In cyclopropane, the carbon-carbon sigma bond are weaker than the normal carbon-carbon sigma bonds due to cyclic structure, and these bond bends together and thus have minimum overlapping than the carbon-carbon sigma bonds in open chain propane molecule. The bed bond deviate from the internuclear axis as these overlapping occur outside the internuclear axis and assume banana shape as shown. Due to this banana shape of bent bond, this theory is also known as bent bond theory. Due to this bent bond or banana bond, the bond angle 60 degree which was proposed by base-10 shaped to 104 degree as shown. Here one thing should be noted that the sigma bond formed by the maximum overlapping between sp3 hybridized orbitals in open chain propane is stronger than the bent bond or banana bond formed by the lesser overlapping between sp3 hybridized orbitals of carbon-carbon atoms of cyclopropane, which in turn is stronger than the sigma bond formed between the two p orbitals due to sidewise overlapping in pi bonds as shown. Higher overlapping of orbitals result in a stronger bond and hence higher stability. This is a side-on view of the cyclopropane. Weaving cyclopropane along carbon-carbon atom shows that all carbon-hydrogen bonds are eclipsed. This is the Newman projection of cyclopropane. Now look at to the structure of cyclobutane. This is the Newman projection of cyclobutane, which shows that these two hydrogens and these two hydrogens are not quite eclipsed. In cyclobutane, the bond angle has been increased to 90 degree from that of 60 degree as was observed in the cyclopropane. Due to this increase in angle, the stability increases. The reason is that cyclobutane the reason is that in cyclobutane, the overlapping between sp3 hybridized orbitals of all the carbon atoms is now greater than that of the cyclopropane. Thus, the increase in bond angle causes greater overlapping between the sp3 hybridized orbitals and hence leading to increase in stability. So that's why cyclobutane is more stable than cyclopropane. These are the various conformations of cyclobutane molecule. Now look at to these structures which indicate the planar structure and the Newman projection of cyclopentane. Here again the bond angle has been increased to 108 degree as compared to 60 degree in cyclopropane and 90 degree in cyclobutane. Here in cyclopentane, the sp3 hybridized orbitals overlapping between carbon-carbon bond of cyclopentane is greater than cyclopropane and cyclobutane. Due to this increase in bond angle, and hence cyclopentane is more stable than cyclopropane and cyclobutane. This slide shows the various cycloalkanes along with their bond angles. From the look of these structures, we can say that cyclopropane has bent bond or banana bond with lesser or minimum sp3 hybridized orbitals overlapping and lower stability. The bending of the bond then decreases in cyclobutane, cyclopentane, and higher cycloalkanes as shown, causing increase in sp3 hybridized orbitals overlapping between carbon atoms and increase in bond angles, and hence increase in stability can be observed. So thank you for watching my video lecture. Please like, comments and subscribe my channel for more new videos.